for coming to this talk after lunch. So this session is named Kubernetes Tower Defense, and it will be about how to implement security, advanced security, and evade penetration inside Kubernetes. First, let me introduce to myself. That is my first time here in Berlin. So my name is Javier Provecho, and I am a Google developer expert in cloud, and I'm also a platform engineer at Telefonica. I will explain a bit later what it means to be a platform engineer, because it's not exactly SRE, and it isn't a security pen tester. I'm also an organizer at Docker Madrid, Cloud Native, and Silicon Valley, that there are local meetups from Spain. So let's get started. How many of you know what's tower defense games? Okay. So as for those that you don't know them, about tower defense games are a lot too old, and they have been cloned a lot. And in fact, the main focus of the game is to build a path where all the enemies should go, following it, and put towers on each side, and you start making the path from the start to the beginning to your base for the enemies to be slower and more painful. And this is something that I will show in the presentation. That is how to make the job for a pen tester, specifically in Kubernetes, but this applies to many other systems deployed in the cloud, to be as most hard as possible. Because usually, unless there is a very common vulnerability open in the internet, it's very hard to, it's very hard to automate this vulnerability, and it's always a process of finding a hotspot and trying to break in and see, okay, what can I see next, and I'll keep advancing. So there are like long iterations, maybe seconds or more, between our commands. So depending on the architecture of our system, that depends a lot of, for example, naming of the services, etc. It makes it harder. So if we start putting barriers and making, for example, different ports or different naming, or just putting firewalls in front, it will be easier. So first of all, that's a defense in depth. It's very similar to playing the tower defense game. So defense in depth in Kubernetes is because Kubernetes is a very open platform, and it has like many open points where you can attack it once you are inside. You want to avoid like having a single defense in your cluster. For example, let's say an ingress controller that you are filtering all the traffic through, etc. Something like that. So what does it mean, all these requirements about all the defense in depth, penetration testing with my job that is currently platform engineering? It's because in my current project, we started treating, it's Telefonica, it's a telecommunications company, and we started treating a lot with big data, especially big data related to customers. So that's very, very important. I mean, to have it safe and avoid like escapes within the platform. And in this case, like security pen testing is not taught at school or whatever. I mean, you learn it from your own system and start trying to hack. One of the requisites of this platform was that we need to execute algorithms on top of it inside Kubernetes. And okay, I just asked the managers, and I say, but which kind of algorithms? Ours? No, third parties. Don't get me wrong, I don't mean third parties from, let's say, other companies, but third parties within the company. So, I mean, you don't control the software supply chain of the other teams, because that's another different problem of governance. So, in this case, we needed to be sure that we could execute something similar to multi-tenant software within a single Kubernetes cluster. So I got my checklist, and I started to see that my current platform is like a huge API gateway that processes all the requests, and it basically uses OAuth 2 or OpenID Connect, JSON Web Tokens, etc. But what happens to the internal traffic? So talking to many other colleges that are using Kubernetes within my circles, they have all one thing in common. That was internal traffic. You don't have it firewalled, or you don't have it encrypted, or you don't have it even authorized. Okay. So how can we deal with this kind of issues, or why they are important? Because you shouldn't have a single line of defense. What does it mean? That are you trusting that your backends will not be able, will not have like a execution, I mean remote execution vulnerability? For example, we all think that, oh, because my application is made in Go, or that is not like in interactive interpreter. I mean, I don't mean nothing to Python, but it's not an interactive interpreter, and I cannot run. I'm not running like an OS run or OS exec endpoint. So that means that my application is secure. Maybe there are other types of remote execution or remote proxying, like the ones that I will show in Kubernetes. So what we could have most of us that we are running. Maybe I can ask a question. How many of you are running Kubernetes in production? Okay, that's a good number. Welcome. So maybe your business software has like mine, API gateways, maybe have like out servers that generate tokens, or maybe they just have admin endpoints. Maybe these admin endpoints, they are not protected within your internal cluster, so they are only protected outside unless you have implemented like an service mesh or whatever. But there are other tools that they are, that's the focus of this talk, that they are the monitoring tools. Probably we all have monitoring tools wide open within the cluster, so maybe your Prometheus instances can make a request directly to any other part of the platform where they shouldn't be authorized. So some features that I would like to highlight from Kubernetes that help at making multi-tenant environments even better are pod security policies that allow how can we interact, or how automated components can interact within the Kubernetes API. And this allows us, for example, to restrict how can you mount volumes, etc. There is another feature that was network policies, that was the real implementation of firewalling within Kubernetes. And the other one is role-based access control that restricted the previous two. So even if you have these configurations within your cluster, you wouldn't be able to edit or revoke them. So you, for example, only have permission for creating services or reading pods, etc. All these three features, I think that they work like at the given time correctly. So. But there have been still some patches that, I mean, there are having a lot of vulnerabilities, a lot of CVEs in the last maybe 2 to 3 years in Kubernetes. But I would like to highlight these three that they are like very important in the other context of our cluster, which is the internal part. The one is subpath. Maybe will be something related to automation with our cluster. If a malicious actor gains access to create pods, they will be able to modify that path when mounting volumes and access other files or other paths, even from the host. The other one that is the most common, it break during the DockerCon Europe last year, is proxy upgrade, and it basically means that when you are making a request to the API server, you could escalate it back. You could upgrade it to like a WebSocket and send fully authenticated request against any other thing into your cluster. And the last one is the cluster scope resources, that it was like a very, very big bug within the API airbag, and it allowed to request like cluster scope resources with just namespace credentials or namespace limited credentials. So we are in 2019, and all of these bugs, all of these vulnerabilities, they have been closed, but we are still using one of the probably most dangerous components in our Kubernetes clusters, and they are like clusters as a service from companies, for example, like Google, Amazon, DigitalOcean, and many other in the list, Azure, IBM, etc. And one of the main problems of this is that these solutions, they are probably added just to keep up on the trend. So all cloud providers must have their Kubernetes service, but they have a second problem that they can't break compatibility once the client has deployed. It's very noisy to, oh, you have a deprecated version of our Kubernetes, you must completely remove it. I mean, it's a very secure practice, but it's annoying for the customer, and if the customer doesn't understand it, it's very hard. So in 2019, a lot of issues have been, they have been passed through the cloud providers. However, they are not like listed publicly. There are like blogs for example, for Armed, that is a security consultant that showed how to break out through Google Kubernetes engine. But all of these issues, they are solved. Let's have some look. So, for example, using Google Kubernetes engine, we have one of the first biggest issues that was when you create by default a Google Kubernetes engine cluster, you could access the service account of the nodes from the pods. And that service account that was intended to be used for the machine has like full project scopes. Let me show that to you. So, for example, if you run a pod within your cluster, no custom service account, so it's all default. It's like any other pod that will be probably running without any security hardening. You could use like a client like curl to access the metadata endpoint. So you start navigating through this endpoint. That is the one that is intended for the machine to bootstrap. And we reach a point where, for security, Google understood that we couldn't access more because doing a HTTP request is like easy. I will show it back in the presentation. So it asks a bit more of interaction, or a bit more of making our request more personal. So it requests us to add this header to the request. So we can still we can keep going doing request. So after that, we can go to instance, sorry for the backslash, and we can go, for example, to service accounts. And we can get the service account. And we can get, for example, the token. Be fast, you can make a photo now. No, but you can, for example, how many of you know that blog post from Armed, the one that showcased how to break through Kubernetes, Google Kubernetes engine security? Have any one of you read it? Okay. So I will make a summary because now it's closed, of course. And one of the things is that these scopes for the service account of the machine, there was a full scope for you that use Google Cloud that was compute. Do you know what the scope compute does? It lets you not only read all the virtual machines in your project, but also write them. So just with this command, that it will be in a single HTTP request, you will be able to escape to your project and not even create like roach pods, but even roach machines. Of course, what's the purpose for mining Bitcoins? So, of course, this is not closed, and we should look for other ways to keep going. This is, the tower defense, the mechanisms that some part of them, they are being done by the cloud provider. Other one, will be our responsibility to do. Other issues of your Kubernetes engine that maybe are fixed, maybe not. Metadata API. As we have seen in the first example, metadata API is still open. What can we get from that metadata? So we are still at the metadata endpoint. We go to our instance, and in our instance we can find this. Let me put it again. Clear. So as many of you will know, the metadata API will let you query a lot of details about our instance. It's a common IP that a well-known IP. A well-known IP that you can access from your initialization scripts within your machine and get dynamic data like what's the machine I am or something other things. And especially in Kubernetes, there is this attribute that is called kubem. Go quick and do a photo. And these all credentials and configuration, of course, but credentials, they are like all the credentials that Kubernetes needs to bootstrap and for doing the bootstrap. And what means doing the bootstrap for a node in Kubernetes? It means that it will need a valid credential set, maybe a password, maybe nothing. I don't think that is deprecated right now. Or maybe it will need a CA and a private key to contact the API server. A CA for verifying the connection to the API server, and its private key for sending the requests in a two-way SSL way. So with that credentials being used, that credentials only have permission for one thing, and that's creating certificate singing request objects in Kubernetes. These objects are auto-approved inside the API server by the kube controller, and this agent that is using the first credentials, the bootstrap credentials, will query that object to get the status and get his certificate back. When it gets the certificate, that certificate are the credentials that let him ask for pods or ask for pods that they are incoming to his node, so it can be run within it. And then there is this other still option that is still available. So Kubernetes read-only port. Who knows what's about it? Do you know about the Kubernetes read-only port? Some of you? Okay. So Kubernetes read-only port is a port open from the kubelet. The kubelet exposes two ports. One is the own self port for the kubelet, and the other one is only a read-only that lets information flow through the outside. You can query it. It was originally intended for Kubernetes dashboards. The original one, Kubernetes, and for other add-ons like Hipster, that was a daemon that lets get metrics from the cluster. But Kubernetes read-only port, as I said, it has been deprecated, but most cloud providers still have it public. So how can we find it? Remember that we are inside a pod. Any of your container images can do it. So of course I'm not talking about the instance metadata, but we need to get something from that metadata, and it's the hostname, because we don't know the IP of the interface that is listening in the machine. We only have, if we try to query that, we only have our IP, the IP of the container. So we need the host. So we'll get it now. And now we can do this. No problem, but we are contacting. Let me put it more clear for you. So this is an API endpoint that exposes all the pod specifications that they are running within that node. And you can get very, very interesting details, like for example, secret names, not sensitive values, unless you are using environment variables in a plain way. But you can get a lot of information, like for example, discovery of multiple namespaces, or getting all the pod names, getting of course their IPs. So you can now query, you can now send direct request, because you are supposed that on a default installation of Kubernetes, you are not firewalling at the first time. So you must think that this, what I'm doing right now, can be done by probably any image in your Kubernetes cluster, unless you have hardened it. So for example, you have a, let me search for IP. So for example, you have both the host IP and the pod IP, and you can query them. And of course, you have the ports. And this can be restricted with a network policy. So it's very easy to restrict it with a network policy because the port is not in a pod, and you cannot use by a label to select, oh, don't let me send traffic to whatever thing that has a label. In this case, the kubelet, because the kubelet is not a pod. So how can we restrict with network policies? We can use the IP ranges and allow traffic, for example, to the whole internet except to the range of our cluster. So we will be able still to communicate between pods, but we will not be able to communicate directly with the nodes. This may have some incompatibilities, like for example, when you are using Prometheus and you are trying to get metrics from the nodes, but there is a solution. Instead of having Prometheus query directly the node, you should make Prometheus query the API server and making a proxy through it. So that will not be covered by the network policy. But of course, that means that you will need to have an appropriate airbag. Let's switch to another cloud provider. What happens with AKS? So with AKS, we still have a Metadata API available, and as I will show you in the next example, the most sorry, I didn't say the solution to the previous one, and it was to use this flag when you are creating your Kubernetes cluster, or search for an equivalent flag when you are deploying your Kubernetes cluster in Google with Terraform or whatever solution you are using. And in the case of Amazon, you cannot, of course, disable or protect this metadata endpoint. So what I would recommend you is to install, for example, Kube2EM that is a proxy that injects an IP table rule and redirects all the requests to the metadata API directly to the proxy, and will apply different roles. So let me show that to you. I will close this pod in Google. So the same, we are running a non-privileged image, just a standard Alpine image with no custom service account, so it won't have permissions. And what we are going to do now, it will be the same as what we are doing in previous in GKE. And I will show you how easy it is. So we start navigating. And we arrive at the same place as in our previous in Google Kubernetes engine, when we have a lot of information. In the case, how many of you are using AWS for deploying your Kubernetes clusters? Okay. And how many of you are using COPS? How many of you are using AKS? Okay, it's mixed. So this is interesting for both of you. When you are in AWS, you have like two options: using the classic Kubernetes authentication or using a custom Kubernetes authentication. That custom authentication for Kubernetes in AWS it was made by Heptio, and it uses like dynamic in real-time validation of our credentials. So our credentials, they are not like forever. And that validation is based on our current AWS credentials. So can we get this kind of credentials? quick do the photo. So as you have seen, you have the two pair and the session token credentials that is created specifically for your instance. But as I will show you next, what can you do with this kind of credentials? I will show you in the last demo of the presentation. Of course, you have a user metadata, but in the case of AKS, you should be at least for now relaxed. For COPS, you should be worried out right now. You should pick up your laptops and start installing Qt2M, because as I can show you right now, how are we on time? Well, okay. So as I can show you now, we still have access to similar things like, for example, I think it was a upper level user data, yes, user data. Oh, yes. That was one of the issues. When you are trying to query user data, you may have like a text file or a shell file, and in the case of AKS, you have a gzip file, but it doesn't have any credentials, as different to COPS. In COPS, you will find the same credentials that you are having in Google Kubernetes Engine. So another thing that was recently fixed in AKS was the kubelet read-only port. We don't have it anymore, although we have the host name of the node we are running. We don't have access to that port because it's already closed. So one of the things that I would like to highlight of, in this case, Google Kubernetes Engine, things that make, for example, my task as maybe a penetration tester more hard is like in all our pod specs. Let me switch back so I can show it quickly to you. We are back in Google. Now they ask for our header. And here, I need to get just the host name to do the query. So when you are querying the kubelet metadata endpoint, as you can imagine, you can see, for example, you can see all the pod specs, and within the pod specs you can find, within the pod specs you can find, for example, environment variables. Let me find one of it. Here, this container doesn't have it. Let me find a container that has an environment variable. So I'm having luck today. In the case you're having an environment variable, there are three ways we can declare an environment variable within a pod spec. One of them is directly name value that makes our the sensitive value within the pod spec empty, or visible if you have access to the pod spec. The other one is using value from, that lets you use values from config maps or secrets, but you can still see the name of the variable, and that in certain cases may lead to sensitive leaks. For example, out servers that have configuration within the name of the variable. And the last one that I recommend you is to use from that lets you use all the keys that they are stored within a configurable or a secret. So you are not even displaying in the pod spec, so nobody knows if that what's inside that secret, even the name of the variables. And about the other one, Metadata API, this is the process that you can follow for hacking through all this node. As I explained before, it was used for bootstrapping and lets you retrieve, when you are impersonating the node, lets you retrieve all secrets, but only corresponding to you. And let's retrieve all the pod specs in the cluster, so even more than the Kubernetes read-only API. But what does it mean only for the corresponding node? I mean, there is a key element here, and is that if you can impersonate a node, there is nothing limiting you from reading all the secrets in the cluster, because if you have impersonated once, you can do it again. Just need to find the pod in all the cluster that has the secret that you want, recreate your credentials, and hack it back again. I would like to quote the security pen tester, Ian Coldwater, that because of the release of Helm recently, it doesn't allow you to now get, for example, from these secrets, service accounts that have elevated privilege level. You know what's the issue, for example, with Helm 2 service account? That it was cluster admin. So following this previous process, you will be able to get a credential in the matter of maybe 1 second or two, if you have Helm installed and have full access to the cluster, not just access to secrets and pods. So yeah, I mean, what I mean with this is that it is still a compromise of the airbag system that a Kube controller approves certificates and requests from any node. And finally, I would like to demonstrate how can I escalate through all of these things in AKS, as I don't have currently a COPS cluster deployed or GKE. Let me switch back to AKS. Okay. Oh. Okay. So let me walk through this process as we have, because we are currently the admin of this cluster. We have more information that a normal pen tester should have. So let me walk through from where I'm getting all this information in a internal cell. So I mean, I'm not currently an admin or whatever. We are going to install a few packages like Python pip, and curl, of course. And what we are going to do is to use the just directly AWS CLI. Oh, let me install it first. As I said, this is an AKS cluster, and those of you that manage an AKS clusters may know this command, that is right. So forgetting the kubeconfig. But here there are like 2 flags. In fact, I put it the region now, but I will show you how from where I could get the region. And what we need is the cluster name. Okay. So to get the cluster name, it's a bit hard because the name of the API, public key is a different ID, so you can get it from there, or you can know it within the cluster. And within the cluster, you have a well-known DNS that is Kubernetes, and you can do nothing with it. So what you are trying to do here is to talk to AWS, not Kubernetes. How can we get this information? within metadata, there is a place called security groups. And within security groups, you have two routes that let you explain the roles that they are being attached to the current instance. However, this is a failure of security because the name of these roles reveals the cluster name. So again, with a very quick, of course, the region is also here in the metadata if you want to check it. So what we can do here now is AKS region US East 1 update give config name hilarious, and voila. Now you can see all the pods within the cluster from an unprivileged pod. Things on how to mitigate this: apply by default Q2EAM, so a different metadata and different credentials will be served to you, so you cannot escalate through this point. So this was everything about how to protect, or at least how to pen test these kind of Kubernetes clusters. So thank you very much. If you have any questions about it, feel free to ask. Maybe someone will make a mic.
Hello, very nice talk. My question is about how did you actually end up finding these vulnerabilities, these insights? Is it some tools that you used, or is it just knowledge about how you work with every day?
So, for example, I started originally finding them by my own, but of course, find out later in the internet that many people had done this before. But the main requisite for me was I needed to build a platform that will run third-party code. So I will try to see, because I knew at that time in moment that many components within the cluster were insecure. So I tried to do what can I do from within the third-party workload running the cluster. And firstly, I started trying to access well-known endpoints, like for example Kubernetes dashboard that was recently closed. The access. So now you need to provide real credentials to that dashboard instead of using the direct service account. And surfing and diving into it, I find the metadata endpoint and found a lot of options. Interestingly, I only found information of how to, let's say, hack Google Kubernetes engine. But one of the clusters that they are running in Telefonica, one of the many clusters that are running in Telefonica, runs on AWS, specifically EKS, and I was worried that almost nobody, in fact I didn't find in Google search, nobody that found it like this. So it was even easier for doing that. So thank you very much for coming.